It's a trilateral partnership between the UNESCO in Paris, France, and the University of South Africa, UNISA, and Itamba Labs, which is a national facility of the National Research Foundation of South Africa. If I try to highlight some examples that we are working on, I would like to more or less to highlight this typical case of coatings that we are synthesizing. These coatings are smart materials. If we coat a window with such a material, when it's hot outside, the heat is reflected from the sun, and when it is cold, the heat is transmitted. So these coatings, once coated on a window of a car or a building, it acts like a smart air conditioning. Other materials on which we are working are materials for solar power technology, such as these ones, for example. As you can see, these coatings are black because they have a tendency and the property to absorb light from the sun and to transfer it in a form of heat. And these coatings are mainly used for the what we call CSP technology, this concentrated solar power, which is the other form of solar conversion parallel to the photovoltaics. Likewise, in these activities, photonics, we synthesize and design and engineer materials which can be used to, such as this one, to purify water, contaminated wastewater. And these nanomaterials, once you disperse them in contaminated wastewater, you expose them to the sun, the water is purified and it's drinkable in effect. An additional activity that we are conducting, which is related also to energy sustainability, is what we call nanofluids. A nanofluid is a fluid which contains nanoparticles, metallic nanoparticles in general. And because a fluid such as this one, an oil, an engine oil, it has a low thermal conductivity. There's a huge loss of energy via heating, and therefore high consumption of fuel. The idea is to ensure that the thermal conductivity of the oil in the engine is higher, is enhanced, and so therefore to incorporate in it nanoparticles of metals, and generally speaking copper. By doing as such, we combine the viscosity of oils, which have a low thermal conductivity, as you can see here, to nanoparticles which have a high thermal conductivity. And therefore, by doing as such, we obtain a nanofluid, and doing as such, we reach high thermal conductivities, and therefore high efficiency, less loss in terms of heat in an engine, and therefore less consumption of fuel. This will be able to be translated to a marketable product and contributing therefore to an energy sustainability worldwide. We need to use some large facilities, and some of them is the accelerator of Itamba Labs here at the Material Research Department. We use mainly techniques that call the Rutherford backscattering, PIXI, photo-induced X-ray emission, as well as air dielectric recoil detection analysis. These techniques, the bulk of them, they allow you to have elemental analysis of the thin films and the nanostructures that we have synthesized. That allow us more or less to check about the quality and therefore the efficiency of their physical properties in the future. And in addition to this experiment that we do here, which allow us more or less further to apply to very large facilities worldwide, that is a synchrotron radiation type techniques. But this is a major milestone before going that route.
Professor M. Mazer's research laboratories are host of postgraduates, postdoctoral fellows, and several senior scientists, mainly from Africa and the South, including war zone countries and underdeveloped nations with a significant female fellows. Professor M. Maza is a Fellow of the European Academy of Sciences, the African Academy of Sciences, the Royal Society of Chemistry, the New York Academy of Sciences, and the Islamic Academy of Sciences. Recently, Professor M. Maza has been elected as Fellow of the Indian Academy of Sciences.
My name is Professor Hulda Shaidi Swai. I'm a professor in nanoscience here in Nelson Mandela Institute of Science and Technology, Arusha in Tanzania. It is a great honor to receive the Oliver Tambo Award after very stiff competition involving 50 very senior and distinguished professors in Africa. I'm excited to be one of the 10 professors, and indeed this is the highlight of my profession. My main aim of this research is to use nanotechnology to develop new anti-malaria drugs using the potent herbal extract as well as the existing malaria drugs which has poor bioavailability. In summary, all anti-malaria drugs available today are challenged by poor bioavailability, short half-life, and toxicity as well. As such, there is a need of addressing these shortcomings as well as developing new anti-malaria drugs. Nanotechnology has revolutionized medicine due to its ability to improve the bioavailability of this compound by increasing solubility, reducing toxicity, and improve dose and dose frequency. This technology will enhance research towards the development of novel anti-malaria drugs from both potent isolated herbal compounds as well as existing drugs which needs optimization. Nanotechnology has been used to revolutionize anti-cancer drugs with very exciting results. My research will actually involve encapsulating both anti-malaria compounds based on herbal compounds and also the existing anti-malaria which are lacking potency into nanocarriers of nanoscale. This will be a good opportunity of developing a product, commercialize it. For the first time in the region, we will be able to come up with our own anti-malaria drug and save millions of lives.
Africa's huge population of young people has the potential to solve global problems, including those that are prevalent in Africa. Many of these problems can be solved through science and technology. Physics represents an important bedrock of these solutions. At the ICTP East African Institute for Fundamental Research, we focus on using physics to make significant contributions to Africa. At the same time, we train others to do the same. The ICTP East African Institute for Fundamental Research, based in Kigali, Rwanda, was established to address Africa's need for better physics education, training, and advanced research. Rwanda's policy of advancement through science makes it the natural location to host a world-class physics center. The institute is located at University of Rwanda and is a vibrant international science hub aimed to become the most important physics institute in Africa. The institute offers a rich program of international scientific conferences, schools, and workshops, some in collaboration with top international physics institutes. It will also act as a node for various physics networks in Africa. The institute's educational and research offerings include Masters of Science and PhD degree programs in physics, postdoctoral fellowships, a visitors program that attracts world-renowned scientists to develop research capacity among African scientists, research investigating condensed matter physics, geophysics, and high-energy cosmology and astroparticle physics, workshops and short courses to build capacity in Africa. The East African Institute for Fundamental Research is a partner institute of one of the world's foremost leaders in theoretical physics, research and education, the Abdus Salam International Center for Theoretical Physics, based in Trieste, Italy. ICTP was established in 1964 and since then has contributed to the development of many scientists and physicists, receiving more than 100,000 scientists over the years. The East African Institute for Fundamental Research receives generous support from the government of Rwanda and is part of that country's science and technology ecosystem. It has been designated a UNESCO Category 2 institute in recognition of its important role in building scientific capacity in Africa. Join us in our efforts to build a prosperous future for Africa through science.
The Botswana Institute for Technology Research and Innovation is a parastatal under the Ministry of Tertiary Education, Research, Science and Technology, established in 2012 to conduct needs-based research and development in focused areas.
We are an R&D outfit of the government. We are mandated to conduct research in view of transforming the economy, diversifying the economy.
The mandate of BITRE is to identify, develop and/or adopt appropriate technology solutions that provide sustainable, innovative solutions through co-creation and collaboration in line with national priorities and the needs of Botswana. The Nanomaterials Division is the research division geared towards molecular level research and development of products. Leveraging on the abundant molecular natural resources that Botswana has to address the needs of the people of Botswana. Nanomaterials Division, focusing on 3 research areas, namely filtration technologies, diagnostics technologies, specialty chemicals. As BITRE, we continue to be actively involved in seeking and establishing partnerships.
When you collaborate, you look at the benefit that you get out of a collaboration. Obviously, it has to be mutual. The person that you're collaborating with needs to benefit. You also need to benefit. Now, as a startup, new organization, we have partnered with various institutions around the world, not just in Africa. South Africa, USA, now we are taking to Sweden. These are well-established institutions that have already provided solutions. Right? Now we collaborate with them so that we can take some of what they have done, we adapt it, and we make it a Botswana solution. So in a way, we want to fast-track our getting to the market instead of do something from scratch.
We invite more local and international companies to collaborate with BITRE to utilize our facilities and turn Botswana into a nation that is strong on implementation of research-based projects that will significantly improve the lives of Botswana and the region. BITRE, Botswana Institute for Technology Research and Innovation. Technology solutions from you to us for you.
The Agenda 2063 is a continental development plan for Africa whose achievement will lead to an integrated, prosperous and peaceful Africa driven by its own citizens and represent a dynamic force in the international arena. Agenda 2063 is committed to ensuring economic transformation that leads to higher standards of living for Africans. Improved education standards driven by a skills revolution founded on science, technology and innovation. Unity in society where democracy and good governance prevail and the universal principles for human rights, justice and the rule of law are pursued. Modern agriculture that leads to food security, improved productivity and production. Development of a blue ocean economy for accelerated economic growth. Protection of our environment and natural resources and the growth of renewable energy sources. Building world-class infrastructure across the continent. Establishment of functional and capable institutions supported by transformative leadership. A peaceful Africa where security and stability is guaranteed and guided by a fully functional and operational African Peace and Security Architecture, APSA. Promoting an African cultural renaissance embedded in the ideals of Pan-Africanism. Full gender equality in all spheres of life. African youth are engaged and empowered. Establishing Africa's own financial and monetary institutions that take full responsibility for financing Africa's development. Access to quality health services and proper nutrition for all citizens. An Africa that commands its place in global affairs, working with partners who will promote and support our economic development. Let us unite to build the Africa we want. Visit www.au.int to learn more about Agenda 2063.